All right, so this is the second half of 10.3, right? Parametric in calculus. And we've done the one formula for the first derivative. Oh, I know Caleb wasn't here for the second derivative, so y'all, let's just review all the calculus from 10.3. dy dx formula is what? dy dt over dx dt. Obviously, given, x is a function of t, and y is also another function of t, right? What is d2y, the second derivative over dx2?
The derivative of dy dx.
The derivative with respect to t of dy dx over dx dt. That's the second derivative. And the third derivative would just be the same thing. Derivative of the second derivative divided by another dx dt. Does that make sense? All right, the other two formulas would be arc length. Well, y'all did all right, so the first few problems I'll assign for y'all is intervals for concavity. Concave up and concave down. What are we going to have to do? When you see the word the word concavity, what does it mean to you? Second derivative. And usually if I'm finding intervals, I've got to do what? You got to find those, but a SIGINT chart. If I'm looking for intervals, I'm going to be doing a SIGINT chart, right? A sine chart. So, and for concavity, it's the second derivative. Increasing and decreasing would be for the first derivative, right? But concavity is for the second. So we need dy dx before we can continue. What would it be? Plus 3t squared over 2t. And a t comes out of the top, right? So that will cancel to be a nice, easy 2 plus 3t over 2. Or even 1 plus 3 over 2t. Would you agree with that? I'm only doing it that way so I can get an easier the derivative, the second derivative, or the next derivative of this. What is the next derivative? 3/2. Yeah. Over another dx dt, which was 2t. Over 1, flip and multiply 3 over 4t. And that's not going to be terrible on the concavity end, is it? The only place this will change signs is where? At 0? Yeah. And the negatives will be negative, and the positives will make this fraction positive, right? So we have concave down from where? And concave up. The only thing that can make it harder, I'll caution you on 41. Look at the initial domain for t. If I have a natural log of t, what's the domain? 0 to infinity. You don't even have to look below 0. So I did like a bunch of work with that. when I was doing some of the problems with them. And even on 43, it's a trig one, but they say only from 0 to pi, so. So that's the first type of problem y'all are gonna add in, right? The second type is arc length. And I did give you that formula last time, I'm pretty sure, right?
Yeah.
It's an integral a to b square root of what? Dx dt quantity squared plus,
dy.
yeah. You were right on a regular arc length, right? Not parametric. But we morphed that, you know, the old one was a to b 1 plus y prime squared, right? And it turns out we used some Pythagorean stuff and morphed it into that. So let's just go ahead and the surface area of a revolution. What do y'all remember about the one that went along with the arc length before? Wasn't it a 2 pi?
Yeah.
So this arc length, area of the surface, or surface area, was 2 pi. What was before the arc length?
4.
The radius, right? And then 1 plus. It's the same thing here. 2 pi, radius, arc length. And of course, what we talked about, I mean, I know we're using A and B, and these are actually values for X, right? But these are actually values for T, right? T is going from A to B. So let's see if we can do like one example of each, and then y'all will have some time. Maybe. What time does this end? You'll have, yeah. All right. So let's do an example for arc length. X equals t squared plus 1. Y equals 4t cubed plus 3, negative 1. And this one is just for arc length. Integral negative 1 to 0, right? Big square root. What's x prime? 2t squared. Y prime squared. What does that give us? This is one instance where I literally think we can do it without a calculator.
2t equals 4t squared.
Right. No, we can't distribute a square root over addition. But we can factor something out of these two things. 4t squared times what? Plus 30, oh no, does 4 go into?
Yeah, 36.
36, right? T squared. And all of that is still under the radical. Now that I have it down to multiplication, that now gives me the opportunity. A square root or powers can kind of distribute over multiplication, but not addition or subtraction. That is, if I had to give the number one issue people have with algebra, is they try to distribute. But I can say, what's the square root of 4t squared? 2t. And then I'm left with the square root of 1 plus 36t squared, right? Now, this looks like a problem I could have right now in Calc AB. It's a blob to a power, right? What power? 1/2. Now, that 2, I could factor it out. I realize that the derivative of this blob will be a factor of 2, or a multiple of 2, but what is the derivative of this blob? 72t, and we've got the t that we have to have, right? So manufacturer 72 and a 1 over 72, right? And now a blob to a power, what's complete? The derivative of the blob that you check off and ignore, right? Add 1 to the power. Dividing by 3 houses, multiplying by what's 18 times 3? 54? Top ones plug in the 0, 1 to any power 1. Plug in the -1. -1 squared is 1. 37 to the 3/2 power. And I refuse to do more. So the arc length will be negative? Why would the arc length be negative?
Can arc length not be negative?
Why would it be negative? Isn't it just a length? It's like a square root. Why is it negative?
Is it because it's parametric, so the arrows are going to the left?
Maybe. Arrows must be going to the left.
That's smart.
Let me see what does the calculator give us? Did you test it?
To what? I'm trying to test it, it just doesn't work.
It's not working.
My calculator went away. Yeah, no, it's still negative.
Because your thing is so small. Your thing is so small.
It did give you a negative?
Yeah.
Okay.
Oh yeah, do that. And then go back there.
So did everybody plug it in? I won't plug it in. All right. So it was a negative, like
It's negative
200 and something? Yeah. All right. So the area of the surface problem this is actually number 68 of right around the ones I'm going to assign. X equals 1/4 t squared. Y equals t plus 3. 0 to 3. I don't know why all of a sudden they do this t is less than, or, you know, I don't like it. But what do we need for the surface area? We need the arc length stuff, right? What's dx dt? Power down, 2 over 4 is 1/2 t, right? What's dy dt? 1. Oh, we need to be told if let's just do 2 of them. A, about the x-axis, and B, about the y-axis. So, A, if we are rotating a figure about the x-axis, somebody tell me what is the radius? The y value, right? So the radius is the y value. 2 pi out here, right? And square root of 1/2 t squared plus 1 squared, right? And all of these have a picture of a calculator. So that if this was a calculator problem, which many of them are, I've seen them on the parametric arc lengths and stuff are on calculator pages. So it is a matter of setting up. Again, surface area is not one that's on there, but why? It's just an extra step, right? So plug and chug on the calculator. I don't know why the decimal always shows up. I must hit the middle bottom all the time. 2 pi zero 3. Is it okay if I call that TX?
Yeah. That's cool you get it down there. Is that free?
Yeah. Oh, where's the,
Math
114.
9.
114.
14.199.
It takes me forever to plug it in mine because the touch sensitive, I mean, it's just weird. What'd you get? 114.1998 to 3 decimals would be 200, but you know what? 199874. AP would accept that. They would just stop, truncate it, and they'd be fine with that. What about if we were going about the y-axis, though? We're taking our figure going this way, and the radius then would be the x value, 2 pi, and just call it 1/4 t squared, right? 1/2 t squared plus 1 dt. I just hit second enter so I can go back and change it, right?
Good. Yeah, they were just saying stuff like that.
Ooh, much less. Is that what y'all got?
Yeah.
21.48.
It was that one thing.
Rounded.
Denny? Who was it, Denny?
Pretty
Just
sure.
joking.
All right. So here is the little teeny extra thing. 86. I might just give you 85 for fun. But 86 has this parametric curve showing the arrow this way, right? And it says 0 less than theta less than pi, x equals 2 cotangent theta, y equals 2 sine squared theta. And the directions say find the regular area. This is just something that as I was looking, I was challenging myself actually. And I was going, I don't even know if I can do this. What would I do?
Just a regular integral.
It is just a regular integral, right? The problem is, it's a parametric. I mean, now I suppose you could eliminate a parameter and try to solve it that way, right? But if you remember when we did regular areas, we always drew, or sometimes drew, a representative rectangle, right? And what is the width? D what? And the height is the what? It's just the y value. So as I was thinking through this, I was going, oh, well, I could just go 0 to pi and just go the y value to sine squared theta. And then I started to write d theta, and I was like, wait a minute. Actually, I did d theta, and I put it on my calculator, and I got the entire wrong answer, and it was actually a specific, non-decimal answer. So I was like a little bit weirded out. But remember when we did the all-out u substitution? Can somebody tell me, because we need a d theta, correct? In order to do this correctly. Anybody, when we did an all-out u substitution, what would we do to get dx? Take the derivative of 2 cotangent theta. What's the derivative of 2 cotangent theta? -2 cosecant squared theta, then tack on the d theta. Does that make sense? So -2 cosecant squared theta d theta, well, 2 times -2 is -4. Anybody know what sine squared times cosecant squared would be? Antiderivative is -4 pi minus 0. An area of -4 pi? I bet, oh, because it's going, the arrows are left, what should I have done? Because we always go normally, but clearly the 0 was over here and the pi was over there, so this is really what I should have done. Does that make sense? So I would have had 0 minus a negative, well, sorry, on the next step. I would have had 0 minus a -4 pi, making it positive 4 pi. That was just a little stretch that I thought. I've never done a regular area in parametrics, but I could see AP throwing something weird like that just as one of their stretch problems. 86 is actually a little bit harder because I think you end up getting like a sine to the 4th or something. I'm at 85. I'm going to assign you 85, but and I don't even know if it's sine to the 4th. It could be cosine. Do y'all remember the
1 plus cosine squared.
1/2 1 minus cosine of 2 theta, right? This is sine squared theta, right? So another sine squared, we'd have to do it again, right? The reduction formula. But you were on the right track. Just giving you a hint. I think I'm going to give you 85 as your challenge problem. But so pages 727 to 729, 39, 41. Oh, let's just go 39 to 53 odd. Sorry.
And 85?
Oh no, I gotta do a couple of the, these just get through the arc lengths.
Yeah, you can take the pictures. Well, I
67,
thought it was Rick too, but he's really wanting pictures.
69, and 71, and then 85. So a few area of the surface. So we got the concavity, arc length, area of the surface, and the one challenge problem.
Today Thursday, or is this this week? Wait, it's Wednesday.